Right, we're going to look at some transformations for functions and graphs of functions. So if we start with a generic function, y equals f of x, there's clearly a graph associated with this on the xy plane. We put in our value of x, we put it through the function, and then we plot our value of y. Okay, so when we do that, we'll get some sort of graph. And we're going to look at when we add and multiply by constants in certain ways, what that does to the graph, how it transforms the graph. So if we have y is equal to f of x plus a, where a is some constant, how does this move the graph? Well, for the same x values, we're going to plug them into the function, and it's going to give us the value of y that we get from y equals f of x. But then we're adding on some constant, so that's going to just that's going to be added on to the value of y. So if it's positive, if a is positive, it's going to move the graph up, and if it's negative, it's going to move the graph down. But we can just generalize that and just say that this kind of transformation shifts the graph a units up, okay? And then if a is negative, that just takes care of itself. You know, moving something up negatively is moving it down. So we can just say this transformation moves the graph of y equals f of x up. Alright. Now, if we do y is equal to a times f of x, well, now say we get a value of y for f of x. Well, when we multiply it by a, it's going to scale that value with respect to a. So if a is 3, all our f of x values are going to get 3 times bigger. Alright, if a is a half, then they're going to get half as big, right? The whole graph is going to stretch in the y direction by multiple of a, okay? So we're going to get a stretch in the y direction of magnitude a. And again, that still applies if we're negative, just if it's negative, it's going to flip the graph over. Now we're going to look at some slightly harder ones. What if we have y equals x plus a? Okay, so now we're actually changing our input into the function. But what we've got to think is, what value of x do we have to plug into y equals f of x plus a to get the original value we had for y equal to f of x? So if we have our function y equals f of x, and we're putting in the value, I don't know, x equals 3, that's going to give us a point y, and we want to say, so now what do we have to put in as x so that x plus a is equal to f of 3? Well, we're going to need to put in x minus a. Okay, so we're going to have to put in x minus a. So this actually, rather than shifting the graph to the right, it shifts the graph to the left, alright? So by a. So if a is 5, the graph moves 5 units to the left. So that's what you got to remember. And if a is negative, then it moves to the right. Now if we get y is equal to f of y is equal to f of ax, well, now in a similar line of thinking, we want the value of x that's going to give us our original value y is equal to f of x is going to be x over a. Alright, it's a little bit weird to get your head around. You'll have to explore it with a few functions, do some transformations with some functions, and you'll start to see why this comes through. with x it's closely related to sort of the ideas of inverse functions and stuff, but x over a and cancels out with that a times x. We just get f of x. That's what we want. So this is a stretch in the x direction, but by factor 1 over a. Okay. So here we have move up by a. Here we have stretch in y by a. We have move left by a, and here we have x stretch by 1 over a. Okay, so the thing, if you just want to remember these transformations, when we're adding and multiplying outside of the f of x, then we sort of do what we'd expect. We move up if a is positive, down if a is negative, and when we're multiplying we stretch in y by the magnitude of a. Okay, but when we're adding a and multiplying a inside the function, we do the opposite of what you'd expect. So we move to the left if a is positive, and to the right if a is negative, and then when we're stretching, we stretch by 1 over a. So hopefully you can start to get your head around these transformations. In the next video we'll look at combining transformations, but for now that's it. If you do have any questions on this, please be sure to let me know in the comments. If you did enjoy this video, please like and subscribe.